Okay, so I'm back talking to you about section 1.8, which is the absolute value equations and inequalities. On the last video, we talked about the equation. What if it's just an equal sign? We know when we have an equal sign, we have just the dots, just the solutions alone, not a region, not a whole part on the number line, just those dots. So now we're going to add in what if it's an inequality. All right, so if you're looking at a greater than or equal to or a less than example, let's think about what would make this true. It's saying, what could I fill in for x when I take its absolute value, it's greater than or equal to 7. Maybe the obvious part would be if it is 7 or larger. You know, if you put in 7, the absolute value of 7, absolute value of 7 would be 7, and 7 is greater than or equal to. It's the equal to part, so it's including that endpoint. But also if I plug in, let's say 8, the absolute value of 8 is still 8. So 8 is also greater than or equal to 7. So 8, 9, 10, all these, and all the little fractional amounts between there. So all the things that way. So greater than or equal to 7 is going to work. But what else works? So if you think about that, what else is going to work? There's another side of this as well. You know, with this section, we said that you're going to have two answers, pretty much a positive and a negative answer. So the negative answer is also going to work. If we plug in negative 7, its absolute value is also 7, and it works for that inequality. Well, okay, so let's say negative 7 works. Well, what else works? Do I need to go this way or over here? It's actually going to be this direction. I need to plug in like negative 8. Negative 8 would be back to the left. So if I plug in negative 8, its absolute value is 8, and that's greater than or equal to 7. Negative 9, negative 10, so it also goes that direction. So you wind up with a split here. You've got negative infinity up to negative 7, and we're going to use a bracket because we have a line under it. We know that means a bracket. And then we have to write the union. And then 7, again, because there's a line under it, I use the bracket to say I'm including the endpoints. And then that would be our solution. For the less than, if I were doing a less than 7, so if you think about 0, that works. 0's absolute value is 0, 1, 2, dot, 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 all the way to 7. If you plug in all those numbers, again, 1, 2, even, oh, not 7 exactly, I guess I should say, because if I plug in 7, its absolute value is 7, which is not less than 7. This one doesn't have the line under it. So I'll use a parenthesis to show that I'm not including that endpoint, just 6 1/2, 6 3/4, right up next to 7, but not including the 7. Then going this way, it's the numbers like negative 1, negative 2, all the way back to negative 7. Once I get over here to negative 8, negative 9, those absolute values are 9, and so they're not going to be less than 7. So it makes this center closed in part from negative 7 to 7, the middle region. So this would be your solution to that. Again, all the numbers from negative 7 to positive 7, all the little fraction decimal values, all values included in that number line, when you take their absolute value, would be less than 7. And notice I did not include the endpoints because there's no line under it. You use the parentheses on that. So that's your solution. Well, so in your handout, you'll see the rule is, so if you have an absolute value of anything, and it is greater than, let's say A for anything there, when you're doing greater thans, it's going to wind up being the outer regions. It's going to be X is less than negative A, and X is greater than positive A. So you have this split, and so that's explained in your handout too. So just in words, it shows anytime you have that, it's going to have the split. So you're going to be using the union sign or the U sign to put the two sections together. So X will be greater than A, but also less than negative A whenever it starts out as a greater than. When we have a less than, like we saw here, if it's less than an A, it's going to be the middle regions. It's going to start at negative A to positive A, and just the middle part between that. So it'll be a more closed region. All right, so let's see an example. So if we're doing an example like X plus 3 less than 7, You know, we always do this. We spice it up, make it a little bit more challenging with the algebra in it. So if we have a little algebra to do in here, we need to include it. X plus 3, we write it as less than 7, but it's also going to be greater than the negative 7. So basically, it's like what we learned in the last video with the equations. You have a positive case and a negative case. For the negative case, though, you're flipping the inequality. The less than becomes greater than whenever that, or it just flips the inequality, which you might remember was kind of a thing with dividing by negative anyway. So the negative case, maybe that would help you kind of associate. When you do the negative case, you're going to flip that inequality. But what we just learned is the less than winds up being the middle region of these two answers. So again, write it like it is, and then solve that part, less than 4. Then over here, greater than negative 10. And if you think about this, it's less than 4, so back this way, less than would be to the left, but greater than at negative 10, it turns it around, and it's greater than. So it winds up being in that middle region per the design of it. All right, and you can check again, anything from negative 10 to positive 4 plugged in here should work. So again, the procedure is pretty much what we did on the last video. You write it like it is. Also make sure this is isolated first. That's still a thing here. So if there's any outliers outside the absolute, get it across, isolate it first. Once you've got an absolute and a positive number, you have two cases. Write it like it is, then write it with the negative case and a flipped inequality. And then whatever you get, you can graph that. So let me give you one to try. All right, so let's try that. Let's say x plus 2. Let's put a number outside that just to say we did. And we're going to do a less than, let's do 20. All right, so again, feel free to pause the video to work that. I'm going right ahead though. I would throw that across the line first. Per the design, I picked one just to remind you, if there's something hanging around outside the absolute, multiplied or added, throw it across first and get it cleaned up or simplified. And so you have an absolute, and if you have a positive number there, that means you're going to have two cases. You're going to write it like it is, what makes x plus 2 less than 19, and then write it again, flip the inequality, so that's a greater than, and then the negative case. And then we solve that, throw the 2 across the line. So x is less than 17, and then here x is greater than negative 21. On a number line, if we think about that, it's going to be the middle part. We kind of just know the less thans are the middle. From negative 21 and then 17, it's between them. But you could also reason less than 17 goes this way, greater than goes that way from the negative 21. So it winds up being the middle part. And it does every time when it's a less than problem. Once it's cleaned up in standard form, where you've got an absolute and a positive number here, if it's a less than, it's going to be in the middle. If it's a greater than, which we're going to see next, it's going to be the outer regions. All right, so let's try one that's a greater than. All right, so let's look at this one. It's already in standard form, the absolute, the inequality, and this is a positive number. That means we should expect two cases. Writing it like it is, and writing it again. Notice the x plus 2 is unchanged. We flip this and change this sign. Bring the 2 across the line. So that's one of our solutions. Bring this 2 across the line. That's our other solution. Now this one is a greater than, so I'm expecting this to be a split answer where we have to use our union symbol. Greater than or equal to means use the bracket from positive 7, isn't it? Positive 7, greater than that, all the way to the infinity, you know. And then less than or equal to negative 11, we'll turn it around this way, and you'll have that section. So again, it's split as per expected. Negative infinity up to negative 11, bracket because there's a line under it, right? Union, and then 7 to positive infinity. And that's our final answer. Okay, so let's do that a couple more times, practicing this. Again, these are you try, so pause the video and please do you try it before you See the answer worked out. Somehow it's just better if you're working it, your brain connects with the moving of your pencil, thinking about it, more than just watching it. It's good to watch it first, but then the U-Tries are built for that reason. It's proven that that is better for your mind. You just get better when you practice it alone. So and also it keeps you from falling asleep listening to me too much, which I know can be also a problem. All right, so on this next example, we throw the 4 across first. The absolute still absolute value, that's not changed. We're just isolating this loose added or subtracted value. It needs to be moved across the line first, consolidated or simplified. Then, if this be of standard form, an absolute and a positive number, then we proceed with the 2 cases. We write it like it is. Once, that's going to give us 1 case. Then we write it again, same old x plus 2, but flip that around and make that a negative. And then solve those 2 cases. So x is greater than or equal to 1. Throwing that over, x is less than or equal to negative 5. Now this is a greater than, so I'm expecting the split answer, but let's see that it's so. Greater than or equal to 1 would go this way. Notice with a bracket because of the line. Then less than or equal to goes this way, negative 5. Again, we write that as negative infinity up to negative 5, bracket, union, then 1 to positive infinity. All right, so procedure there. Things to remember as you do these. Now, this next one kind of makes a little bit of an exception to what I just said there. So let's talk about this example. I think it's going to make an exception to the pattern because I have a negative on my x, but let's just see what happens. Follow the procedure. It's an absolute value problem, inequality, positive number, so I'm expecting it to be solvable. So write it like it is. Write it again. Don't change this. You know, we're saying what makes this 9, what makes this negative 9, and then flipping the inequality. So I'm bringing the 5 across the line. I'm going to have to divide by a negative sign. Now remember, when you divide by a negative, it flips the inequality around. So it makes it greater than or equal to negative 4. So that rule still stands. Over here, same deal is happening. I've got a negative x. So I'm going to have to divide out negative 1. And we know with inequalities, that's a big rule. Inequalities, the inequality gets flipped when you divide or multiply by a negative. So let's see how that looks on the number line. So greater than or equal to negative 4 means go this way. Oh, but look at this. Oh, it did work out actually. Less than or equal to 14. I was afraid, we had to move the signs back and forth so much, but the less than still became in the middle. But it did, you do have to tread a little more carefully on this one because the negative on the x, you had to flip your inequalities yet again, even though you just flipped the inequality, still following those procedures, but it all works out in the end, and that should be our answer, a less than with it in the middle. So negative 4 to positive 14, again with brackets because of the line under it. The last thing is the special cases. So I've been mentioning this all along. If you have absolute equal to negative, you're just not going to be solving those normally. We cannot have absolute value equal to a negative number. There's just no solution to that. We can't even have absolute less than a negative number, right? That would make no sense. That's still, you can't take the absolute value of anything and it be less than a negative. Well, absolute value of x greater than a negative, well, that's always true. So these are just kind of think about on the negative problems. Think about, well, is this not, you know, for these 2 cases, definitely that can never happen. Absolute can't equal the negative, and it can't be less than a negative. That wouldn't make sense. But greater than a negative, yeah, absolute value is always greater than a negative. The special case with 0 is, can absolute value equal 0 though? If it says what makes the absolute value of x plus 2 less than or equal to 0? Well, it can't be less than 0. So that part's not happening, but it can do the equal to 0. Absolute value can equal 0. So we can do the one answer to that would be what makes the part equal 0, the one and only answer. Even though it's an inequality, we can't do the less than part, but we can make the equal to part at negative 2. That's the one and only answer to that part. All right, so I'll come back in with you on the next section. I hope that helps.